Hi, good afternoon. We are here today to discuss today's problem. I'll go through 3 questions today. So to answer these questions, we require to do some maths and also it requires some skills of calculus. So the first question for today, and the question is question number 1, which says derive the government purchase multiplier and tax multiplier using calculus. So the question says derive the government, G, purchase multiplier and tax multiplier, and again you need to use calculus. Now so let's say we have a closed economy, and then we have the GDP, or the income of the country, is equal to consumption plus the investment level and plus government purchases. So by a closed economy, we mean that we don't have export or import, means NX, which should be another term here. So that is not here. And by not having a trade or export and import, we call that economy as a closed economy. But if an economy engages in trade, then we call this a market economy. Now, we assume for the purpose of this problem, we assume that this economy is a closed economy where we don't have the imports and export. Now, as we say here, the GDP, Y is the GDP or the income level, and also C is the consumption. And also we have I as an investment, and G is a government purchases. So for all of this, where C, the consumption, is represented by this formula where A plus B times Y minus T, and also some level of investment, and also some level of government purchases, where T is a lump sum tax. So T is a lump sum tax. So we have said that in this equation, I'm going to write it again. Consumption is represented by A plus B times Y minus T, where B here is a marginal propensity to consume. In economics, the marginal, or MPC, propensity to consume, or MPC, is defined as the proportion of an aggregate raise in a pay that a consumer spends on the consumption of goods and services as opposed to saving it. So marginal propensity to consume is a component of Keynesian macroeconomic theory, and it's calculated as the changes in consumption divided by the changes in income. So marginal propensity to consume is depicted by a consumption line, which is a slope line created by plotting the changes in a consumption on the vertical Y. So here, that's consumption. And this is income. Sorry, income. So the changes in consumptions on the vertical y-axis, and the changes in income is on the horizontal or x-axis. So the marginal propensity to consume will be a straight line like this, which is a marginal propensity to consume. So the marginal propensity to consume is equal, again, as I said, changes in consumption and level of consumption divided changes in y, in income. And for example, let's say if consumption increases by 80 cents, so that's 80 cents. If in the consumption increases by 80 cents of each additional dollar of income, then the marginal propensity to consume will be equal to 0.880 divided by 1, which is 0.8. So this brings us to the question, why marginal propensity to consume is important. It is important when we come to an economy of policy or economics of policy. When we have a data on a household income and household spendings, what the economists do is that they can calculate the household's marginal propensity to consume by income level. And this calculation is important. This calculation is important because marginal propensity to consume is not constant. It varies by income. Typically, the higher the income, the lower the marginal propensity to consume. Reason, as income increases, more of a person's wants and needs become satisfied. Then they go into the other mood, which is the opposite of spending. In economy, we call that a saving money. So they're going to save the money instead. But at the lower income levels, marginal propensity to consume tends to be much higher, as most or probably all of the income of that individual must be devoted to subsistence consumption. Subsistence consumption. So subsistence consumption economy directed is the basis of a provision of food, clothing, shelters, rather than to the market. In short, it is an economy which commonly provides a minimum or minimal standard of living. Let's get back to the proof. So we are asked to prove. So we say we let the consumption to be represented by this equation. Now we're gonna sub the C equal, which is C is equal A plus B times Y minus T into our main equation, Y is equal C plus I plus G. So when we do that, then we get Y is equal A plus B times Y minus T plus, they say that's some level of investment plus some level of a government purchases. The key here is, to solve for Y. How we do that? Let's just simplify this. So we have Y on the left-hand side, and then we have A plus, let's multiply this term. Then we have B times Y is BY. Then is minus times plus times minus is minus, B times minus T. So B times T. Again, we continue with writing the equation. So some level of investment plus some level of government expenditure. Now we have to collect the terms, collect common terms, and then we see that we have Y here and then we have Y on this side. Then nothing else here is common. So we bring this BY on the other side. Now the sign, if you can see, is positive. Bringing it on the other side of equality, the sign will change, becomes negative. So we have Y minus B times Y is equal, write the same thing, whatever is left here, A minus BT plus some level of investment plus some level of government expenditure. Now we can take as a common denominator, we can take y, we can factor out y. So y, and then if you do this, then this becomes 1 minus b. And that is equal to a minus b t plus some level of investment plus some level of government expenditure. Now we can write this as, because we are solving for y, y is equal 1 over 1 plus b. Remember, where b is equal marginal propensity to consumption. So don't forget this one. And then that is multiplied by a minus b times t plus some level of investment plus some level of government expenditure. Now, in order to calculate or derive, so this is the equation for a government spending multiplier. But then now we need to take a derivative of y with respect to g, because we are trying to derive the government spending multiplier. So to derive government spending multiplier, to take derivative of y, which is dy, with respect to g. So that's what we need to do. So let's do that. So with respect to g, and that is equal. So we have these 1 over 1 plus b. Again, remember b is equal to marginal propensity to consumption. Just I write it in short and represented by b. And then when we take the derivative of these terms, this whole thing, with respect to g, so there is no g here, there is no g here, there is no g here. So all these three terms, their derivative with respect to g is equal to 0. The only place we have a g is this place, and the derivative of y with respect to g, and this is equal to 1. So we have 1. So therefore, derivative of y with respect to g is equal 1 over 1. Sorry, this should be minus. This is minus, it's not plus. So this is minus as well. So this is 1 minus b, my bet. So it's 1 minus marginal propensity to consume. Or you can write it 1 over 1 minus b. So both of these answers are acceptable as long as you mention that b is equal marginal propensity to consume. Mind you that here I and g are exogenous. So what do we mean by exogenous? By exogenous variable is the one whose measure is determined outside the model and it is imposed on the model. So that's what we mean by exogenous variable here, because I and g are exogenous. Now we can do the same thing for to calculate or derive a tax multiplier, and then we can do that by taking the derivative of y equation we have with respect to t. So we had the equation, if you remember from previous page, y is equal 1 over 1 minus b, and then we had a minus b times t plus I, some level of the investment and some level of government expenditure. So we need to take the derivative of this y with respect to t. And then if we take that, then we have 1 over 1 minus b. And then let us do the derivative of this with respect to t. So there's no t here, so derivative is 0. Then we have the derivative of this second term with respect to t. Then the derivative of this term with respect to t will be minus b. And then there is no t here, so the derivative will be 0. And then the derivative here as well will be 0 because there is no t. So the derivative we have is minus b. So the way we write it is equal minus b over 1 minus b. Or you can write this as minus marginal propensity to consume over 1 minus marginal propensity to consume. So both of these answers are acceptable. And that's your tax multiplier for a government in terms of tax. Again, here, as I said, I and G are exogenous. Their measurement is outside the model. It's determined outside the model, but it is exposed on the model. So these are the two, and you can do it. It shouldn't be any problem if you do it. For it will be a little bit of complicated when you do it with import and export. But the good example is that it's a better place to start with a closed economy model. Now, for the second question, so the question is asking to assume the following model of economy with the price level fixed at 1, and then there's some information is giving where they say C is equal 0.8, and that's times what you income minus what you pay as a tax, and then the investment is equal 800 minus 2R. R is the interest rate, and then also GDP is equal consumption plus I plus some level of investment, some level of government purchases, and then we have the money supply, and that is equal to 1200. Also, we have a tax level, and that tax level is 1000. The government collects as a lump sum tax, and the government purchases is also 1000. And the money demand per P is equal to 0.4. That is Y minus 40R. So these are the information that is giving in the question. And for part A of the question is asking, write a numerical formula for the IS curve, showing that Y as a function of R alone. So we are asked to do this. Now, we have the equation right here, and this is where we have to start and substitute whatever information we have. So Y, we have the consumption here. So instead of C, we have to substitute this one, which is 0.8 times what you earn as an income minus what pays the taxes. And then that is plus, we have 800 minus 2 is an investment. This is 800 minus 2R. It's actually a 20R for investment. Yeah, that's a 20R. It makes a big difference, 20R in a calculation. And also we have the government purchases, which is 1000. So this is what we have. You have to do some multiplication here. And then by doing this multiplication, you will get 0.2Y. And that is equal to minus 800 plus 800 minus 20R plus 1000. As you can see, these two will cancel each other out. And then you have 0.2y. So if calculating by y, divide this both sides by 0.2. And then you will get, like this one is 5,000. And that's minus 100R. So that's our equation number 1. Now, the IS curve is related to the level of real GDP. It's the level of real GDP. And also we have the real interest rate. So the real interest rate. It incorporates both the dependence of spending on the real interest rate and the fact that in a short run, real GDP rate and the fact that the real GDP rate equals the spending. So what do you mean by equal spending? So when there is in a short run, the curve will look like this. This is IS curve. Since it is a short run, so the real GDP here is determined by the aggregate spending, and this IS curve is downward sloping, as you can see it, because the real interest rate increases. When this real interest rate increases, what happens is that the level of spending will decrease, and that's why in a short run it will display as a downward sloping. Now for part B, we have, the question is asking, write a numerical formula for LM curves showing that y is a function of R alone. So now y is a function of R. Y as a function of R. So how we do that? So that is equal to 0.4y minus 40R. This information is given. Now by plugging this information, you will get 1200 over 1, and that is equal to 0.4. That's y minus 40R. So by now, let's calculate and then solve for y, then you will get 3000 plus 100R, and that's our equation number 2. For part C, it's asking what are the short-run equilibrium values of y, r, y minus t, c, I, private saving, public saving, and national saving. So that means that we got solved 2 equations. We have 2 equations. One equation 1 we solved in part A, and then in part B we have equation number 2. So now we use the 2 equations to solve for all those information that we are asked. So the first one was 5,000 minus 100R, which is equation 1, and then equation 2, as you can see it here, and that is equal to 3,000 plus 100R, and that's equation number 2. So if we add equation 1 plus 2, if we add it, then that becomes 2y, y plus y is 2, and then we have 8,000, and these 2 terms will cancel each other out, so that is equal to 8,000. And calculating about y is equal to 4,000. So now we solve for y. So when you solve for y, it is very easy that you can calculate, because we saw that the taxes the government collects is 1,000. So y minus t is equal 300, and then solving for r is equal to 10, and then for consumption is equal to 0.8 times y minus t, and that is equal to 2,400. Same thing for investment. Investment will be equal to 800 minus 20R, and that is equal to 600. So here, the private saving, so private saving is equal to Y minus C minus T, and that is equal to 600 by calculating this. And saving public, that is equal to T minus G. This was 1,000, and this is 1,000. So therefore, the public, the government doesn't spend nothing, because whatever it earns as the tax, it's the government uses as its purchases. And therefore, we know that the national saving is equal private saving plus public saving, and that is equal to 600, because the public savings are 0, and this is 600. So the national saving is the 600. So these are the information that you are asked to calculate. And then also for part D, it's asking, assume that G increases by 200. So G increases by 200. So this 200 could be 200 billion, 200 million. So it's not like $200. We are not talking here about $200. So by how much will Y increase in a short run in equilibrium? And what is the government purchases multipliers and the changes in Y divided by the changes in G? So we have equation where government, before it was, the purchases were 1,000. Now this one increased by 200. So that is now 1,200. So that is equal to $1,200 billion. And then it's 1.2 trillion. And then we are asked to calculate for Y. So Y is equal to 0.8. And then we have Y. The tax the government collects is 1,000 plus 800 minus 20R, plus the government purchases increase from 1,000 to 1,200. Therefore, when we do the calculation, we get 0.4Y, and that is equal to 1,200 minus 20R, and therefore Y is equal to 600 minus 100R, and that is equation number 3. So here we have equation 2 and 3. So equation 3, as you can see, we derived that is 600 minus 100R. That is equation 3. And then equation 2, which we derived before, that is equal to 300. And that is plus 100R. So here again, we do the same thing we did in the first example, add 3 to 2. By adding 2 to, we have Y and Y by adding, that is 2Y. Adding 600 and 300, that's 900. And these two, because plus and minus, these two will cancel each other out. Y is equal 900 divided by 2. So that will be 4,500. Now, the government we need to take the derivative of what is changing in Y with respect to changes in government purchases. And therefore, we saw that the government purchases have increased from 4,000 to 4,500 minus what the government used to spend divided by the increase in the government, the changes in government purchases, and that is equal to 1.5. So the government purchase multiplier has increased by 1.5. So that's the the other questions, and now we have one more question, and that is, let's do, so this question number 3. So the question is asking the following, or the question reads as follows. Suppose a wave of credit card fraud causes consumers to use cash more frequently in transaction, and use the liquidity preference model to show how these events shifts the LM curve. So answering this question is always helpful when you draw 2 graphs. One, a graph which describes the market for real money balance, and also the other graph that is LM curve. So let's draw a normal market for real money. So we have M, money supply, product, and we have level of money supply over prices, and we have the curve. It looks something like this, and this is a level where we have the interest rate and also the income, and this will be the level of interest rate. So let's say that is the initial interest rate. So this is the market for real money balance. And then we have the other one, where it says the LM curve. So we have the interest rate, and also we have some level of Y, and that's, let's say, Y1. And then it is upward. We call it LM, let's say 1. And that's the equilibrium at this level of interest rate. So now when you draw this draw this 2 curve, you can now read the question. So what is the question is asking? The question is asking the following. It's saying, suppose that a wave of credit card fraud causes consumer to use cash more frequently in transactions. So people are turning into using their cash because there's fraud with the credit cards. And then the consumers are forced or encouraged to use a cash most frequently in a transaction. And then the question is asking, use the liquidity preference model to show how these events shifts the LM curve right here, how this is shifts and how this curve will be shifted. So consumer desires to use cash more frequently. This is established from the question. So what this is cause, it caused a demand, which is the money demand here is an exogenously increased, and the money demand curve, it will shift it upward. So you can say upward, it will shift it because there is a demand for money increases because people will be here. And that's the new level of demand for cash. And what it does, that this will be our new equilibrium, and that's the new interest rate. So at the initial value of income, the interest rate must rise to restore the equilibrium. So it will increase to restore the equilibrium here in the money market. And the LM curve will shift up as well. So this one will shift up as well too, to a new level of LM2. So it will shift, and each value of income, such as the initial income, is associated with a higher interest rate than before, because then now is a higher interest rate because this is going up as well. So again, if consumer desires to use cash more frequently, money demand will exogenously increase, or there will be a shift to the right in this curve, a demand for money, and that is each R and Y pair will be associated with a higher money demand than before. So the R and Y will be associated with a higher demand of money because people are not using their credit cards. Now they are turning into cash, and they are frequently using cash. So by using cash, the demand will go up. And this is associated with a higher money demand than before. So then the liquidity preference model, the model demand curve shifts upward. So in the liquidity preference model, like this, the money demand curve will lift afterward, right or upward, and then this will cause the interest rate to increase. Also, at the initial value of income, the interest rate must rise, and this is why, because to restore a new equilibrium in the money market. As a result of this increase, the LM curve shifts also upward, and each value of income, such as the initial income, is associated with a higher interest rate than before, so there will be an increase in interest rate as well. So again, it will be always easy to draw these graphs, and then it will be easier to use the model and then explain to see what happens to LM curve. Until next time, I'll stop here. If anyone has any question, please, you can send me an email, or you can write it in the comments. Thank you.